可以 share 荧幕吗？
Okay, share your screen.
You can try. Just try sharing the window since that failed. Just dismiss and share only the window because I don't know why that fails.
Okay.
Is that okay?
Yeah.
Okay, thank you.
Yeah, perfect. 可以接了。
Okay, so
So now I'll do full screen. So I'll do slideshow.
yeah.
On this one.
So at that time, John Maeda is your professor?
When I was at MIT, yes.
Yes. And to my knowledge, that
looks good on the meeting.
yeah.
Okay, so
Yeah.
okay, yeah. So to your knowledge, sorry.
Yeah, to my knowledge, that one of the creator of processing,
So Ben Fry and Casey Reed are
yes.
generally. So Casey and
your
I
classmate?
classmates, yeah, and he went to UCLA, and we were still in touch.
Yeah. Okay. 好 ，OK， 不好意思耽误大家一点时间哈。今天呢，我们非常荣幸邀请到我们上周跟大家极力分享推荐的这个，我认为是我们这个时代AI art 的，对我而言是启蒙对这个时代来讲，我觉得未来会是个大师那大家如果有兴趣的话可以上网看一下他的作品有的不算太贵几十块美金他都有点乱卖但是东西的思维是很深的。那I apologize for I'm using Mandarin to introduce you. It's more quickly. So 那这个 Tom White 他在非常早的时期有一位我也非常敬仰的大师叫 John Maeda。John Maeda 是之前在 MIT Media Lab 应该是he's the leader or like
he was in charge of the aesthetics and computation group. So Media Lab is split up into many different groups.
Yeah.
He was in charge of the aesthetics and computation group.
Yes. So he's one of the key person in Media Lab. 大家应该知道 MIT Media Lab 是麻省理工学院创造了媒体在建筑系底下的媒体实验室。那全世界最聪明的人呢，都聚集在那里。那在非常早期的时候，在全世界都还不太了解的时候，这里就聚集了一群天才。那John Maeda 后来去了这个罗德岛艺术学院，虽然他是在 Media Lab 那 Media Lab 里面有很多跨领域的学生，那现在也都是都非常厉害那之后去了罗德岛艺术学院当校长，之后又去了一家非常大的，全球可能有超过40% 以上的网站都用这个服务来架设的，就是 Automatic 底下大的服务就是 WordPress 在 Automatic 待了一段时间，那现在他去哪我有点忘。John Maeda who is maybe working in the business area
Yes.
Yeah， 那他现在进入商业的世界那在那个非常非常早期Media Art 或者所谓的 Media 都还是一个创新的时候Tom White 就在 Media Lab 里面就学，那 John Maeda 是他的老师，然后跟 Tom White 同期的人呢是现在在我们这个 Media Art 或者是这个领域里面非常重要的 Processing 的这个 Creator这个 Casey Reed 跟Ben Fry 然后他们是同学所以 Tom White 也是非常非常早期就 join 在这个所谓的Media 的这些各种的实验里面那是我觉得那个时代是非常非常非常有趣的。那我觉得这个时代会开启一个新的那样子的时代，所以我觉得有这样的一个机会跟了解一下他过去所做的事以及他现在看到的东西，我觉得非常非常非常的宝贵所以相信呢大家可以在待会的分享当中可以看到。那他现在呢也在纽西兰全职教书，那也是教跟这方面有关的事情。那也希望呢大家待会有空的话随时有什么样的问题也可以跟他做各种交流。 OK， 好，那 So we are really happy and a pleasure. It's our pleasure to have Tom right here and to share something about AI art and some perspective about blockchain and blockchain art. And let's give him a really large applause. And like, welcome.
Thank you.
Please start sharing.
JC, how long does the class go?
Yeah, the
4:15, 4:20?
Originally that it designed for you can long lasting like around 5, but we won't use a lot of time.
Just
So
checking,
you can
yeah.
you can end earlier and have some QA.
Okay.
Yeah, because I think in this generation students need some time to think
Yes.
and talk, right?
Okay, good. Thank you. So thanks for that great introduction. My name is Tom White. I'm going to give you 2 talks. One of them I've given a few times before. It gives a little bit of background about myself, and it talks about some of the artwork that I've made. And the second one is a new one, which I'm still putting together. If you feel compelled to ask questions, you can blurt them out at any time, but I'll have a break at the end where we can talk or have a discussion. So this is the outline of talk number 1. This one will be about 45 minutes or so. This is about the art I've been making for the last 10 years. So I'll just tell you kind of right away what the point is. I'll talk about some precedents in art. I think it's useful to talk both about the technology and about other examples from the art world that inspire me. Then I'll talk about I'll go through kind of a list of things that I've made, objects, and I'll go through basically some of the art that I've made, and I'll end up talking about some of the newer things that I've made. So what's the point? So if you fall asleep, don't fall asleep for 60 more seconds, because this is the summary of the whole talk right here. So I think that computers or machines have their own ways of seeing. Okay. Oh, so microphone. Yep. Should I talk into this? Yeah. Okay. Better. Yeah. Hello. Oh, wow. Very loud. Okay. So here are the core ideas in my artwork, is that machines have their own way of seeing. So they see similar to us in some ways and different in some other ways. And so I'm interested in making art for and by machines. And I think that through this art, we can appreciate the ways that machines perceive the world, which might be similar to us and it might be different. So that's it in a nutshell. What's the point of doing this? I'm interested in how machines read images and how they look at images and how that might be different than the way we do. There's a term that's come up that wasn't really in vogue when I started doing my work, but it's something that I'm more interested in, which is about how computers are aligned to human preferences. And so I went through my talk recently and I flagged some things because I think it's an interesting way to dissect my work as well, is to point out when there's a misalignment between the way that computers and humans view things. Okay, so a little bit about me. As JC was saying, I've been interested in creative coding and the intersection of technology and design for a long time. My first kind of AI-related project was at SIGGRAPH in 1995. And in early forms of AI art, there were different ways of doing generative art. This was using genetic programming. So genetic programming was a lot. Carl Sims was really a giant in this space, and he was an artist that used genetic programs to come up with different systems that people weren't programming explicitly. And so this applied that to video interactions. When I was at MIT, I was working with John Maida. My interest initially was in human interface because of my background doing human interface, and I was doing my master's thesis was on a multi-touch interface. So years before there was an iPhone interfaces, I was interested in how those might work and how you could use those on the computer. I did do a lot of art at the time, or a lot of media art, but it was more in installations. So this is one of my more, this was something I did in 1998. It was called Stream of Consciousness with my collaborator, David Small. And we had words projecting onto a stream. And there was actually some AI in this one, in that the words, it was using something called WordNet. So if you've heard of ImageNet, it's based on WordNet. And that's, it was using WordNet and you could select words as they flowed by, and it would come up with similar words. This is actually fun footnote on this one. It was toured. It went to Ars Electronica, and for many years was part of their tour. And the last place it toured was in Taichung in 2005. And I think after that it was mothballed, so I don't know if it still works. But it has been exhibited in Taiwan before. And this was another thing that I did when I was at the Media Lab, was a drawing framework called ACU. ACU was a core part of our work at the Media Lab. It was a drawing toolkit, and we had like a window system. One of the students made a text editor, but this was the library that all of the students shared to get when we were doing our sketches. And the reason that I bring this up is that JC talked about processing open frameworks. These both of those libraries were based in part on ACU and the work that we did inside the lab. Basically, there's a genealogy where these projects kind of evolved from each other. But by and large, after that, there was a nice. This was another footnote. So this was John Maida tweeting just yesterday, if you look at the date, because he was reminiscing on our days at the Media Lab. And JC mentioned Golan a minute ago, and David Small and myself. I'm Drew for what that's worth. But then after that, basically, it was AI winter. I stopped doing my interactive, or I stopped doing a lot of my artwork having to do with AI, and I worked in the industry for a number of years. But then about 10 years ago, AI started getting interesting again. So I started doing work, and that's what this latest series is that I'm going to tell you about. So before I do that, I'm going to talk about a few precedents in art, or a few things that I think are interesting to know about in the art world that at least inspired me. So probably the biggest figure to know in space is Harold Cohen. So Harold Cohen was a classically trained painter. He was very well known in Britain. He went to international art fairs. And then after he was sort of a famous painter, he decided to get into computer science and AI. And he spent over 40 years experimenting with generative drawing systems. So this started in the 60s and 70s. He went to Stanford AI Lab. He worked there for a while. And he was really kind of the grandfather of a lot of generative art ideas. At the time, they didn't have even color screens. And so he's making these machines that would paint his ideas out. This is an example of an output from his most well-known program, which is called Aaron. And Aaron was basically code that he wrote to try to come up with drawings that matched his idea of how compositions should be put together. But the thing that I think was interesting about Aaron, and later in Harold Cohen's life, that's Harold Cohen. I visited him about 10 years ago when he was working on this piece that's on the right. And he's most well known for Aaron, but actually he used Aaron later in life, not as an autonomous drawing program, but as a collaborator. So he would draw a little bit, and then Aaron would draw a little bit, and they would go back and forth. And I think that's it's interesting that his work evolved in that direction. But the reason I bring him up is that he actually had a philosophical question that he was trying to answer in his work. And that was, what is the minimum conditions under which a set of marks may function as an image? And here by image, he doesn't mean like, a 640 by 480 pixel group. Great, thanks. Yeah, basically he was learning how to perceive and represent familiar objects in new ways. And his way of doing that was forcing himself to look at the same thing over and over and over until he could see it in a new way. So I'm using that as kind of a starting point in my work. And my question is similar to both of those other artists. And can we use, instead of using sort of forcing yourself to see something day after day, can we use computer vision to introduce us to new ways of perceiving and representing familiar objects? So now I'm going to talk about my exploration in answering that question. So this is some of the first work I did, and it was in 2017. And so at the time when you're looking at how computer vision systems work, they're based on data sets. And they're data sets of any particular item you want to learn is going to have 1,000 images. or more for the training set. So these are 1,000 images which define what an electric fan is supposed to look like. And this is from a famous training set that's used in academia called the ImageNet training set. It's used for benchmarking vision systems. So what I did was I made a drawing system that would you can actually morph from one to the other. So you can start off with an iron and you can just kind of move all the strips around and make something that looks like a so this is a cello. This is one that I thought was really interesting. The computer vision systems, when they're using these data sets, they don't know exactly what the object is. So here, it looks like you sort of see a cello in the foreground, but you see something behind it, and I'm assuming that was a cellist. I had the system look up what in the training set looks like the image that got produced. So that's one way I can kind of reverse engineer what's happening. And indeed, it says that these images on the right are the ones that most look like the image that it generated. Take a second to look at it. There's one thing that's very different about the image that of the cello that it drew compared to all the ones that are in the training set. See if you can figure it out. The one thing that's different is, and I didn't notice this at first, is that all of the cellists in the training set are right-handed. And if you look at the way that it drew the cellist in the painting, is actually left-handed. And that's another example of something that's slightly misaligned, because the way these systems are trained, they're blind to left-right symmetries. So actually, it can't see left-right symmetries because of the way the training set works.
I'm sorry, your looks like that.
Okay. Sorry, I don't know. Let's give it 2 stars. I do have a. Yeah, I have that actually. Yeah. Okay.
好，用它的，用它。
我跟你没有网路线。
I'll let you do that part.
Sorry about that.
It's okay. Should I use the microphone? Is it
Yeah,
useful?
you can, or yeah,
What,
up to you.
up to me. I'm going to not use it.
Okay, okay.
All right. Can people hear me okay?
Yeah.
Okay. A couple more, and then we'll be done with the series. So measuring cup is another one. I don't know how many people have measuring cups in their kitchen to measure, how much milk to use. My measuring cup doesn't look anything like this one that it drew. If you look at the ones on the right, most of them don't look like that either, but some of them do. It's this crazy colored green, right? So I don't know that I'd ever seen a measuring cup like that. So I looked in the training set to see what that was. And it turns out that there's a weird green measuring cup called depression glass measuring cups. These are glasses that they actually have a little bit of uranium in them. They were made 100 years ago before we knew that was a bad idea. And people buy and collect these online. And when they were building the data set for the measuring cup, they got scraped in with everything else. And that's an example of sampling bias. So sampling bias is when you're building a data set and you get too much of something that's not representative of the real world. And so that's why the measuring cup ended up green. Again, that's an example of a kind of a misaligned concept. Tick. So tick is, do we have ticks in Taiwan? No. But we know what they are.
Yeah.
So tick is this was one of my least popular by sales because people don't want paintings of ticks. But tick was an interesting one because it was so strong. So what you can do is the response on this one, when you measure how the systems respond, the vision systems, when they see this tick, it actually the scores are higher than any other tick it sees. In fact, this is on the right is called the validation set. So in machine learning, when you're training, you test everything on the validation set, and the validation set is sorted from strongest to weakest. And you'll notice at the bottom row, these are spiders. They shouldn't even be in the validation set. That's why they're the weakest. They don't look like ticks. But at the very top is the painting. the drawing that it made, which is interesting because it actually it's a super stimulus from the vision system's point of view. This has some precedent in comic books. So Scott McCloud talks about how by removing features, you can actually amplify a response by simplifying it. So if you're trying to represent a person in a comic book, you don't draw all their features. You draw some of their features. If you draw too many features, it looks like a particular person. But if you take some away, then it could stand for a greater number of people. Okay, just a little bit about my process. So these are all screen prints, or I moved into screen printing after doing that series. Screen printing is used a lot with pop artists. Like you've probably seen Andy Warhol or Roy Lichtenstein, but a little bit about how that works. When you're doing screen printing, like to generate the image on the right, which is a chicken, you actually have to plan that out for 2 different layers. So the drawing systems plan out for 2 layers, and then that gets transferred onto screens, and then that gets printed out manually. So I have to put that on the screen and then just kind of smash some ink through what's essentially a fancy stencil. And these are some of the first screen prints that I made, and these were exhibited back in 2018. Again, so this is sort of a different present. One thing that I did about here is I also made sure that these were registering on online systems. So this is what's on the right is a Google Vision system online. You can show an image to Google Vision. You maybe use Google Lens and ask it what's in the photo, and that's its response to these prints that I made. So this is the rabbit data set, but you also have Google Vision responding that that's a hare or a rabbit. This is killer whale. Penguin. Again, the categories that Google Vision gives it is kind of funny. Penguin, flightless bird, and then particular kinds of penguin like emperor penguin. I did custom data sets. So this is eyeball, and this is an example of one that kind of looks crazy, but it is recognized by a face or a facial expression or eyebrows by Google Vision. And then another thing I did at this point was I started exhibiting these in groups because I thought it was more interesting to see the family of things that could result from these algorithms instead of a single instance. And then you get a better idea what the visual language is that the systems are working with. So for example, this is chickens and eyes. And here's another one that I did at that same period, which is called 9 knots. Knots is a funny concept because the concept of a chicken like this, you kind of have an idea what the features of a chicken are, right? Like it's a beak, it's feathers, it's maybe some feet. For a knot, it's much more abstract. It's more about how the shapes relate to each other. And so it's a more abstract idea about how those shapes can be parsed and to be seen as a knot. And then I did another one with even more sort of, I filled the room with images of ants. So these are different ants. Again, the system chooses the shapes, but also the colors. And so not surprisingly, the ants tend to be black or red. And the backgrounds are usually green, but you'll notice there's a violet in the back because if you look at the training set for the ants, a lot of times they're pictured on flowers. Okay, so we made it to through that work. The main thing to get out of this is that the machines have their own way of seeing, and you can create art for and by machines. And by using machines as part of the process, then you can sort of understand better how the machines are perceiving the world. There's another series I did about this time where I didn't concentrate on objects, but I concentrated on other vision systems, specifically pornography filtering systems. So I've covered these up as kind of cheeky because these are things that will trigger offensive systems. So if you might be offended by this, cover your eyes now. But here's the actual prints. So these 3 prints were the first 3 I did. Here's an example of another one I did called Mustard Dream. And when you show Mustard Dream to Google, it considers it adult or racy. If you show it to Amazon, it considers it explicit nudity. And if you show it to Yahoo, it considers it not safe for work. So even these different systems don't have the same names for these concepts. And we can't, of course, we don't have their training set, but they still all somehow get triggered by this abstract print. even now, if you go to Google and you type, what did I type in there? I typed like,
Let's start free.
yeah, Mustard Dream DribNet. Then it comes up and it says, well, here it is, but I'm not going to show it to you because, say search is on and I blur out all these dangerous images for you. So obviously that's sort of misaligned, right? Because we wouldn't expect that to trigger these systems. Another funny footnote about this is that I was, Architectural Digest wanted to put one of my prints in their magazine. They wanted this one because it was the most colorful, and I tried to tell them maybe that was a bad idea, but they didn't kind of. So when I got a copy of the magazine, a physical copy, I took a picture of the page that it was in and I sent it to Amazon, and it was 80% sure that there was explicit nudity. So I think that's the first cyber centerfold in the real world. I did a few more of these. So this is another print illustrated nude. It also triggers Amazon and Google. And then I did one called Blowjob in 2022. Again, Racing Adult. So those are different kinds of concepts, right? So those are filters that are out there trying to protect us, trying to take actions for us, and they're getting triggered by these prints that I make. And that's one of the things that I think is interesting. I have a picture of a circuit board up here because it's kind of in my mind a symbol for the fact that this is a print that's kind of actionable or gets interpreted by these systems. So like if I show the 6 chickens to AWS and I say what's in the scene, it sees that there's a person and it sees that there's a chicken, and it doesn't make a distinction when it sees this between a painting of a chicken and an actual chicken, right? So it'll take actions, and the same with the sort of the synthetic pornography pictures, right? Like it actually takes actions like blurring things out based on what it thinks it sees. So in the same way that Magritte was saying this is not a pipe, that triggers our recollection of a pipe. That the machine learning systems are doing kind of the same thing. This comes up even when I'm doing when I'm getting ready to do this talk. So I was going through my phone and trying to figure out like things I can include in this talk, and it my phone is helpfully sorting all my photos all the time, and it says here's some animals and food and things. It thinks these are bananas. It thinks I have a whole bunch of bananas, which print of a banana. I did some scorpions. It thinks I have scorpions. A weird one that I did once was a syringe, and for whatever reason, I have a real picture of a syringe, and then this weird multicolored syringe. But in the mind of the phone, these are the same thing, right? Like it's both bucketed these in the syringe category. Another print I did, eyeball and face, when I printed that one out and I went to take a picture of it on the phone, it actually put a little yellow square around this part of the image, and that's because that part was optimized to look like a face according to a face detector. And so that's how cameras work, right? When they see a person in the scene, they highlight the person, and that was triggering that part of the camera system. And then there was a separate time when I was exhibiting the Mustard Dream with the print I told you about before, and I went to post it on Tumblr, and it actually didn't let me post it because it thought it went against their community guidelines, and so it refused to let me post it on their Tumblr blog. So all 3 of those examples, I point those out in a category because they're showing how, like, here the phone is kind of actively organizing my pictures, or the phone, the camera on the phone is trying to find people, or things aren't allowed to get posted. These are actions that the machine is taking on my behalf, and I guess in all these cases they're kind of misaligned because it doesn't know the difference between sort of the paintings or the abstract versions and the real versions. So that's kind of a summary up to here. So there was, I did the objects, I did this not safe for work imagery. There's a few other things that I thought I'd go through quickly. One thing that was kind of the first stage of my work. In the last few years, we've had these text-to-image engines, which I'm sure you've all used or tried out. I played with these for a little while, and I was interested mainly in these because no longer now that natural language works so well, we're no longer restricted to preset categories. So before we could only do chickens and electric fans, because in order to train these machine learning systems, you had to, the step one was to create a training set. And now you have access to, through the way that the language systems are trained to the whole human experience of what we can talk about. So this was a print I did, crystallization. And these, I was using a limited number of colors. And again, the colors are chosen by the vision system. The thing at the bottom is just the registration mark, so you can ignore that, but that's how I kind of line up the colors. Veins of a leaf, again, so veins of a leaf is something we all recognize when we see it, but you probably would never build a data set of just pictures of veins of a leaf. Or another one that you'd never build a data set of is raindrops on a windshield. So probably we've all experienced what raindrops on a windshield looks like, but why would you build a data set of thousands of images? But if you ask the system to draw it, it draws something like this, which, interestingly enough, if you show back to the vision system, it says, oh, yeah, that looks like, raindrops on a windshield or on a piece of glass. And one other one that I did was shatterproof glass. So if you think about what shatterproof glass looks like, just visualize it for a second when you might come into it. It probably doesn't look like that because this is kind of the opposite in my mind of what I expected shatterproof glass to look like. But if you do a Google search of shatterproof glass, you'll find exactly images of that, because shatterproof glass is often, the way these systems are trained now is they take images and captions, and they assume that the thing in the caption matches the image. And if you look at the images that go with descriptions of shatterproof glass, often it's advertisements showing shattered images. So I thought that was kind of a cute example of how these systems can still be misaligned with our expectations. And there's one other one I did, which was a reactive drawing. So this was a little bit, I was inspired here by Harold Cohen's collaborative work, and I wanted to do something that was more of a collaboration with the system that I was making. So in this system, this was meant to be a collaboration where I'm putting down part of the object and this responding. The way it works is I start off with an eye, and there's an eye that ends up on the screen, and then it draws around the eye. I give it a, similar to the text to image engines. I gave it a theme, and the theme here is puppy dog eyes. I chose a lot of captions that had something to do with eyes, and then it would draw around it. But then the trick is that I'm allowed to move the eye, and as I move the eye, the drawing itself can update itself. And the way that this works is it's based on the way that the text to image engines work. They usually bottom out in creating an image. So there's a back propagation that happens, and then you sort of optimize the image. I actually had a separate network behind that, which so the effect is that the network, when it still has a feed forward step where it can at runtime, it can move the eye around and it can react to that. So there was a few of these. So the eye moves around and it can update the drawing based on where the eye is. And I did prints of these as well. So when I'm doing these online, I'm often influenced by the idea of printing these. So the prints follow the same process where I print the eye. Here I just do it by drawing, and then I do a screen print on top of it. So I'll show a couple from that series. So this is Turn a Blind Eye. And this was maybe one of my favorites. It's called Look Mom, I Can Fly. And notice that as the eye moves around, it seems like this object is rotating in 3D to follow the eye, which is pretty remarkable if you work backwards on how this works. So, there's an eye and there's a drawing, and the drawing is being updated based on the eye direction. And so the system is kind of reacting to the direction of the eye. So the input to the system is which way is the eye looking, and then the subject then is updating that based on the eye direction. And then that's the print of that one. And then the last one I did, this was last year, was looking at actions. So a lot of the things I talked about before were specific objects or nouns, but I was interested in so I did an early study in 2021 about what jogging might look like. So there's, just like we have data sets of electric fans and cars and animals, there's also data sets of actions that for learning videos. And if you show this video to these vision systems, it thinks it's seeing someone jogging. But the way that I did that one was just kind of as a print where I did individual frames, and I wasn't really satisfied with how that worked as a print. So this past year, I updated that and I have a different system now. So this is a print I did of the, again, there's a system that's used, or a benchmarking system that machine learning people use that tell whether these vision systems are working, and it's called kinetics. And so this punching person is a category in the DeepMind kinetics data set, and this is what it looks like. When it's interpreting this, it actually unrolls the frames in this. So this is what the preview looks like, but then the print gets printed out as a particular frame. So this is the petting cat category, and this is what it looks like when you unroll the frames. Blowing your nose, or blowing nose, is what the category is. And push up. So again, so this is just me trying to extend my techniques to handle verbs or actions in addition to particular objects or concrete nouns. Okay, so I think we've gotten probably through the talk. Let's see, machines have their own ways of seeing. We can create art form, yep, and through our research. So this was the first slide I showed a while ago, and we've gotten through those ideas. And that's it for my first talk. We'll take a deep breath, and I'll take any questions if there's any, or if we're going to have a discussion. Yeah. Sure.
I'll optimize the result, or looking for the optimized data set, or how to make sure it looks great, or how to make sure it will be recognized by the algorithm. It's animal, or just how to optimize the result. Right?
Yeah, so I'll show probably the easiest slide here is to show this one, which goes through. It starts putting down some of the primitives, and then it looks at them all at once. It doesn't move them one at a time. It kind of moves them all at once. And it's not optimizing a particular image. It's optimizing kind of a distribution of images. So it's, if you look at it, you'll notice that the color seems to change a little bit because it's looking at it in different lighting conditions and things like that. The key to the optimization is that it has to be kind of a lowish number of primitives. So there's not
偏粉红色猫的灭绝，这样你听得懂我意思吗？当然，这是一个很极端的思考，但我想要讲的是，我们现在的对于事物的认知，其实正在慢慢的被我们并不知道的演算法跟 AI 所影响。那超快的 work 其实 remind 我，其实有很多这样子的一个所谓的共通性跟联动的效果，正在出现在我们的生活当中，而且我们并不容易知道。那我们其实正是创造出这些演算法跟这些 AI 的人，所以我觉得台湾其实更是如此。所以我其实为什么很积极的想要把窗外的东西带到台湾的原因是，我认为未来如果有一种演算法会让粉红色的猫灭绝的话，那应该有很大一部分的几率是台湾人做的演算法。所以我希望在这个过程当中，我们每个人都知道，这样子的事情其实虽然它看起来不像大洋，但是它其实影响很深。Sorry, maybe I cannot perfectly translate it.
I understood some of it. Yes, how might or not this year.
I just want to tell them that and start from it's not political reason, but it might end up with a political results. 虽然我的开头并不是因为政治，但是希望大家可以思考一下，其实机器跟人这样的一些认知的同与不同，其实很可能会导致人类社会未来跟政治有关的。这我就不说，到底人与人的政治不会有核的政治，还是人与 AI 的政治？我就讨论太多。Okay, so I just want to tell them that the timing that I met you or your work
online. It's just the timing that I'm aware there are some politician or like some influencer online on Facebook. They are trying to posting kitties photos. Their kitties with them or like cute kitties, and they don't know why they upload the image about the kitty, but being removed by Facebook algorithm. And then they get a screenshot and put out some memes and say it's crazy why kitties are pornography and why it's like sexual related content. They don't understand. And I collect a few cases and I found out there are something similar, that the kitties is normally white, but a little bit pink. And then I think that if those type of algorithms tend to recognize a pinky cat is a pornography or sexual related content, in long run, maybe 50 years or 100 years, a pinky kitty will be,
It'll feedback on the system. Yeah.
We will get a real human feedback, but in another way. And then no one will want to try to adopt pink kitty because no photo will be able to upload. So it's crazy because it's not only a notch effect that in EU they're talking about. It's our actions will be moved by a machine action. So and without any proof. So I think that's very, very interesting questions.
And one problem with that I've had recently is that more and more, like when I was doing this 5 years ago, you could always go back and look at the training set. But now the training set is the internet. Like really,
yeah, it's crazy.
There's no way to look at the training set,
yeah.
And it's also possible to take something out of the training set.
Yeah. So you can say that in the future, which types of kitty will be popular or will be extinct will be decided secretly by algorithm, by our social network algorithm, right? But it's conspiracy or crazy ideas. But I think it's just a small example, or like just a small crazy discussion or ideas. But similar cases might happen or show in unwanted scenario or time that might influence our rights or our living. So I think I talk to the students because most of them or half of them are computer science backgrounds. So I tell them that if in the future there are some algorithm make a decision or slowly make a pinky kitty being extinct, then those type of algorithm have a 50% chance it's written or contributed by Taiwanese excellent students. So I think Taiwan is one of the key places make and push the AI generation, and we made it, and we should aware about those type of effects made by us. So that's why I'm really involved and trying to introduce more your thoughts and your work to Taiwanese art gallery in front of people.
Yeah, thank you. Yeah, it certainly is surprising that this ever tricked an algorithm. Yeah. And it's even more surprising it's doing it for 5 years, right? So
yeah.
For 5 years, you show this thing, people say search and it doesn't want to show it. So something is, and it is starting to feed back on itself.
Yeah. Yeah. Thank you. So okay, we can move into thank you.
So that was my more boring talk. Because it was all about me and it was all about stuff that I'd done. It was talk that I've done a few times before. This is one I kind of put together and it's not fully baked. It's kind of a half-baked collection of ideas. But maybe with some discussion at the end, you can help me. Oh, I lost the connection?
Yes.
Yeah.
Okay. Let's see if I can.
Am I back?
Yeah.
And go here. Oops. I'll watch you do it this time, so I can do that. Great.
So this is
I'm going to turn myself down. Okay, good.
Fine,
All right.
Yeah.
This is a different talk that I'm giving that I haven't given before, but it has a basis on this other artwork that I did a few years ago, and it's trying to go back to my roots at the Media Lab and generative art in general, and how that relates to the blockchain. So the outline of this talk is generative art essential vibes. So I'm going to just kind of throw out, I don't have a good argument for this yet, but I'm going to throw out what I think is the core interesting thing about generative art. I'm going to show an artwork that I did a few years ago called Metropolis. This was right when art blocks and everything was kind of blowing up, and I wanted to make my own version, and I didn't really know why, but I think I now know why, and I'll explain that. I'll contrast that with art blocks a little bit. I'll talk a little bit about fluid art versus solid art, and that'll make more sense as I get to it. I'll close off with another art reference, which is the Ashcan School. I'll be very impressed if anyone knows what that is, but I think it's an interesting parable and it relates to generative art today. And then I'll talk about what I want to do with all this and why I'm talking about it. Okay, so this is a very bare bones slide. My apologies if some of these slides are bare bones. I was actually working on it this morning at 8 a.m. and something else happened. You might be aware of what happened. I wasn't able to finish my slides all the way, but I think I got most of it there. But I think that the essence of algorithmic art is that it's infinite, alive, and explorable. So when John Maida was talking, I've heard him give talks, and he said like the time that he got hooked was when he was a kid and he was programming and he realized he could do a for loop. Like you do something once and then you can do it 5 times or 10 times or as many times as you want. And it's kind of this engine of power that is really really captures your imagination. And I think that kind of that sort of idea of infinity and that something keeps running and it's alive is part of what makes algorithmic art. There is a book called 10 Print that I'll reference here. And this is a book about a piece of code. It's a single line of code that's shown on the cover of the book that prints out a maze, and it used to be run on the Commodore 64. I just am pointing it out as a loose justification for some of my claims, which is that once the computer can do something once, sort of the core qualities is they can do it over and over again. In this case, it ends up drawing a maze from this one line of code. So now let me talk about what Metropolis is. So when art blocks came out, maybe it's good to actually jump to it since I'm on my own computer and we can look at it and kind of figure out what it is together. So you have to put yourself back a few years. In 2021, art blocks was coming out. There was this other blockchain called Tezos, and Tezos had something called Hekinic, and it was kind of a chaotic scene. And I saw what art blocks was doing, and I wasn't really happy with it, and I wasn't sure why. And I decided to make my own version of what I thought would be better. And so this is Metropolis, and there at the core there's a single large generative space, but you have this Google Maps kind of interface where you can zoom out. You can go kind of left or right. You can do that with the mouse as I was doing before, or you can just, like, if you don't know where you want to go, you have a roll the dice button, so you can hyperspace to different location. But the idea is that this is an algorithmic space you can navigate, and if you end up in an area that you like, you can sort of do the equivalent of taking a photograph. You can generate or you can capture that location, and when you capture that location, it will show you a higher resolution version of the space you're on, and it'll give you an opportunity to mint or claim that. So here is the kind of where you were. Also interesting in this, or also what I thought was central to this, was that it had this social component to it. So below this are all the locations that other people have found and join
And share.
Share is this button?
Yes. Yeah.
And then
we
this.
No. That S. Yeah.
Okay. All right. So that's tour of Metropolis. It was like something a little bit different. It was kind of weird and quirky, and a lot of people showed up and experimented with it. But looking back on it now, I actually have a better idea of what it was I was trying to make. So I think I was a little disappointed with how generative, so this is a field I've been in for a long time, and I was a little disappointed in how generative art was being framed, and how it was being sort of packaged and sold, if you will. And so Metropolis at its core is infinite. You know, you can spatially, you can move all around, you can zoom in and out. It's alive, like the code runs indefinitely. Like it's not like, you know, like you can show up. I did this for 3 years ago now, and you can still show up on the site and explore it just like you did then. And you can explore it randomly or from a checkpoint, and the checkpoint can be from something, a link that your friend sent you, or, you know, there's different sort of entry points into it. Now, I'm going to compare that a little bit to ArtBlock. So I just put up an image here of ringers and Fidenza. I don't know if people know what ArtBlocks is, but it's one of the more famous or well-known generative art platforms in Web3. And when it came out, these are actually fairly coincidental to Metropolis. So the one on the left, Ringers by Dimitri, came out a few months before Metropolis, and I think Fidenza came out about the same time. I'm going to look at Ringers specifically, and I think it's a really great piece, by the way. So I think it's really interesting what it captures. What I'm disappointed with is how ArtBlocks kind of presents it or packages it. So this is a single image that comes out of Ringers, and what's on the right is a collection of those images. It kind of gives you an example of the outputs that this system can generate. But in the end, what gets minted is 1,000 of those examples. And so if you look at how ArtBlocks works as a platform, it's finite. So you get exactly 1,000 outputs of your algorithm, and then it's over. It's inert. So once those are created, it's kind of dead, right? So the algorithm doesn't live forever, but the outputs of the algorithm live forever. And the outputs themselves are uniformly sampled. They're random, right? So there's no story behind any particular output. It's just kind of chosen haphazardly from the possibility space of what could happen. And I think this was what I was kind of pushing against some of these conventions. So here again is Ringers. There's a single instance on the left, and you can kind of see now the family of outputs on the right. Now, I guess the question here is like, well, is that, you know, going back to why is this disappointing? Like, is there another way to talk about essentially how the algorithm works, or this parameter, the algorithmic process? And there is. This is actually something that goes back to when I was at the Media Lab with John Maida, and we developed for his classes something called parameter vision. It was actually his inspiration, and he got his inspiration from this from Bill Mitchell's book, which talks about this artist, Etienne Jules Mary, who made sculptures like this. And so the idea of the sculpture is that you could see all possibilities at once, right? So you could see a bird flying, but you don't see a single photograph of it. You actually spread out and kind of smear out the temporal aspect of it. So, and this was actually done in the context of grading and evaluating work that the students were doing. This is a screenshot from Casey Ree's thesis, I think, from '99. And we developed this parameter vision system so that we could look at kind of like a compound lens, like a fly would have, where you can look at all these possibilities at once of what's coming out of the system. And they're kind of spread out in a grid like this. So the question is what can you take these ideas of parameter vision and apply them to, well, one way of kind of navigating and wrapping my head around what might be better than this ArtBlocks is to say, well, can we take this parameter vision and use it to kind of explore or understand the space of possibilities more? So here's a version of Ringers that I've done. I've shown this to Dimitri, and he's a fan of it. And here I've taken a specific output of the Ringer system, and I've spread it out across the different variations that are possible if you look at the internals of the system. It's not showing you the complete space of what's possible, but you can actually navigate this and mentally map this a little bit better. So as you go down, there's more of these pegs. there's a logic, a visual logic to what it means to move across this space. It's kind of like a map of what's possible in this. And you notice that there's even repetition up here because some of the parameter space is redundant. But this kind of gives you an idea, like essentially what the art block is doing is throwing a dart at the dartboard, and this is showing you the dartboard or a section of the dartboard, which is the possibilities that can come out. A better way to understand this is, or a good way to understand this is to take a particular output from the ringer system. So if you take it, this is a well-known output of ringers because it looks like a goose, and so it's called the goose. But you could take this one and you could plop it into that parameter space. I didn't do a very good job of drawing it, but it's right here at the screen square. I didn't do a good job of highlighting it, but it's right there on top of the parameter space, and that kind of shows you, if you kind of dial the different parameters, what the different variations of this output could have looked like. So with just little tweaks, some of the parameters, you could have gotten a different result. So I show this as kind of an example of a different sort of entry point into how these algorithms look. I'm gonna combine that with an idea, which is the title of this talk, which is fluid, which is the idea of fluid art. And this is borrowing heavily from a talk that Kate Compton gave recently. So Kate and I have interacted a few times, and she's super smart, and she's been looking at this space for a while. And she came up with, she was looking at AI art, because one of the reasons I'm interested in this is I think all of these ideas that generative art, like traditional algorithmic art, has been kind of the vocabulary that it's been struggling with. I think that these are becoming more and more relevant because they're all the same concepts and technologies and the same set of problems as AI art. And I'll kind of explain that as we go through the next few slides. So in AI art, this is her introduction, is that people know how to draw a cat, and then you can ask Midjourney or these drawing algorithms to draw a cat. But of course, like I said, the power of the computers is that it doesn't get tired. It can just repeat itself ad infinitum. So it can draw not 1 or 2 or 10 cats, but thousands of cats. And what she argues, and I think this struck a nerve with me, is that once it's drawing sort of an unlimited number of these, it no longer registers the same way. You don't really soak this up as an individual, as a collection of cats, but you soak it up as kind of a space of cats. And she calls this a fluid space. This is actually something that I resonated with, because as I said in my first talk, a lot of times when I was displaying my artwork, I would do it in collections, because I felt like a collection of outputs really captures the logic of what the system is trying to do better than a single output. So like when I showed the 9 knots example or the ants example, you can really kind of understand the algorithm more by seeing like lots and lots of outputs from the algorithm. But in AR, the algorithms are spitting out all these images, and even if you look at headlines for like Google News, you'll notice this fluid metaphor. So people will say like, we're drowning in images, or we're being inundated with a flood of images from these images. So there's always like kind of liquid metaphors that people are using to describe this, which I think is, as she says, is not a coincidence. It's because there's something that's fundamentally different or different when we experience a system that can generate many outputs like this. And so she alludes to a problem where this came up 10 or 20 years ago with a researcher who was researching Bach. So Bach, when he was alive, made exactly 1,128 compositions in his lifetime. And there was a researcher using kind of early forms of machine learning. His name was David Cope, and he made something called EMI. And EMI was an attempt to kind of capture musical decisions and musical decision making. And he wanted to capture how Bach's sonatas were written. And he did a great job. He did such a good job that he could have his system generate a synthetic Bach sonata, and then he could show it to experts who were experts in Bach, and they would say, yeah, that's a pretty good. That would, if you didn't tell me that was made by a computer, I would have thought that was a B- Bach sonata. So he kind of had his system. It was scoring well on all those metrics. The problem is that when he went to so he said he had the system and you could push a button and, you know, all these sonatas would now come out, and he wanted to try to get real orchestras to play them, but they all refused. They weren't interested in playing any of this music, and he didn't understand why. And when he asked them, they came back with an interesting comment. And he says, well, because the system was continuing to pump out music like a spigot, again, more fluid analogies, it became a problem of why play this sonata and not that one? Because there was kind of an infinite variety of them, the orchestra couldn't figure out in their head the value of how you would select any particular one. So what David Cope did, and this was kind of a drastic solution to his problem, is he went back to the source code and he deleted. First, he had an output about 1,000 to 2,000 particular sonatas, and he saved those, and then he deleted the code so he could no longer generate any new ones. Okay, so now he's kind of burned the source code to his program, and he only has the outputs. And now the orchestras would agree to play it. So now they thought it was worthwhile because he had basically generated scarcity by destroying the golden goose, by destroying the generator of the music. And this should sound familiar to you because this is going right back to how art blocks works, right? So this is you have to sort of have this system to get value out of the system. You have to constrain the number of outputs. So that's the thinking, at least anyway. Kate coined this problem a Bach faucet, which is where you can have a situation where a generative system is making an endless supply of something, and even though it seems like those things have value, as soon as it's making an endless supply of them, as soon as it's not rare, it's no longer valuable, and so this becomes a problem that we see over and over again. So stepping back, so I'm going back to that idea that the AI art is a different kind of art, or particularly because it's a type of generative art, it can be experienced in a different kind of way. Because it's not, I guess the idea here is that what if it's not just like, what if these algorithmic art, what if work generated by algorithms is not just like more of it? What if it's meant to be experienced in a different way or appreciated in a different way? And there's a Greek term for this, which is autotelic, which is kind of how do you experience algorithmic art kind of for its own purpose? I think a lot of the art blocks was kind of skeuomorphically adopting the conventions of the art world, where you have to have, you know, an artist and a limited number of artworks and they get sold. But what would it mean if we kind of started from scratch and we thought about how we could generate an appreciation for liquid art, for art that kind of or is it possible to appreciate algorithmic art without kind of limiting down to the number of outputs? Do we have to burn the source code and make only a certain number of outputs to find value in it? So I think that generative art doesn't have to exist just to make the outputs. I think that it's a medium to be experienced directly, and that it is possible to make a medium or a way of appreciating that is alive and infinite and explorable, just like the qualities that we appreciate in the algorithms itself. So how do we design for a liquid art space, or is this possible? And I'm not sure, but I have some starting points for that. And I think there are things that some of them are based on what we're doing now, and some of them are a little bit different. Or maybe that's impossible. And if it's impossible, maybe Art Blocks was right, and maybe we do have to compress this generative art down into solid form. So liquid art is kind of where we have all the possibilities, and then the solid art is kind of traditional art. So there's different ways of exploring this space. One is I showed you before, and it's kind of the collage or the random outputs. Sometimes these, this is kind of like what Art Blocks does. You have a collection of outputs, and you can use any one of those as a starting point, or you can across them kind of appreciate what the algorithm can do. I showed you a second one a while ago, which was a geometric space. The geometric space is nice that you can think about that one a little bit differently. You can sort of navigate it and move around in it and think about how it works. You can also use it to be the basis of operations. So this is a program that my graduate student did a few years ago, where we're looking at typeset or font generation based on machine learning models, and we generated a spreadsheet. And the key idea here is that you can use interpolation and extrapolation to kind of navigate. So if you have two different typefaces, you could look at what's in between those. You can interpolate, and then you can use one of those as a starting point and interpolate to another one. So you can kind of grow organically possibilities based on navigating a geometric space. And then the third one is an important one, and this is one that I kind of hinted at in Metropolis, but I think could be done a lot better, which is how to explore socially. This is a slide, again, I borrowed, and it shows it in a different domain where you have this tree generator. But the idea is that, you know, one person could be working on something and they could save it, and then someone else can kind of use that as a starting point and they can modify it. And so there's an interaction here between how this algorithmic space and this social space. And so basically that people like to find and explore these spaces and to name and kind of put pins on the map. And then that could be a starting point for other people to do that as well. And that's what like I said, I tried to hint at that with Metropolis. And so as you looked at like how things were collected, a lot of times an object would, or an item would be collected, and the next one to be collected would be based on kind of proximity to one that came before. All right, so all that was a little bit vague, but I'll close off by giving a reason at a high level why I think this is interesting, and it's the parable of the Ashcan school. Does anyone know what Ashcan school is? Good. So you're not supposed to know what it is, because it's kind of surprising that well, I'll just tell you what it is. So when you look at this painting, does it strike you as avant-garde or risky or different in any way, or does it look like just a fogey old painting to you? You don't have to answer me out loud, but just think about it. Like, to me, this when I look at this painting, it's not particularly striking. It doesn't look like it's going against any conventions. But the Ashcan school at the time was considered the avant-garde of art. So this was a period between like 1900 and 1910, a little over 100 years ago. So this is Shop Girls by William Glackens. This is Robert Henry, who was one of the founders of this movement, Snow in New York in 1902. And the big innovation with this art movement is that they were painting the real world. So you had people that were going out into New York and they were finding scenes. They weren't these kind of stuffy, bougie scenes of someone in a sitting room. This was like someone out in the streets and painting the real world. And here's another one by George Lucas called Street Scene. So all these kind of look like things you might see, but at the time, the crazy thing is, to me, looking back on this, is that these were challenging. Like, people didn't want to collect them, mainly because they seemed out there. They just seemed too crazy, and they were challenging this, like I said, this Victorian decorum with these boldly realistic paintings. And so you have this period of time, maybe 10 or 15 years, where they were defining the avant-garde of art in the United States, until the 1913 Armory show. So there was a big show in 1913, and that's when Matisse and Picasso and Duchamp got introduced. So you started seeing artwork like this, and then suddenly that seemed more radical than what came before. And there's a nice quote on the Wikipedia page about the Ashcan School, which is that they were seen by many art levels as too radical in 1920, and by many more as old-fashioned by 1920, or 1910 and old-fashioned by 1920. Okay, so what's the point of bringing this thing up? I think that that's an interesting parable, because I think that, in my mind, we're kind of done the same thing with generative art. I think that a lot of the generative art that's been made in the last few years, it seems really radical and kind of out there. But I think it's not as radical as it should be. It's like it's kind of halfway there, and it's a little frustrating to see for me. But I think that AI art, we're going to see this moving a lot faster. And I think a lot of the things that we think now, like a lot of the art blocks work, or a lot of the what you've seen kind of in OpenSea and generative art, I think that it's actually going to seem a little bit traditional in 20 or 30 years, because I think we're still sticking closely to kind of the traditions of the physical art market. And I think we're also not embracing generative art as its native form. I think we're kind of looking at it as a solid art instead of a fluid art. So that's my prediction, and we can all come back in 20 years and see if I'm right. But I think that the Ashcan School is an interesting example of how you can be very avant-garde one day, and then 5 years later, you're kind of you're looking very traditional. So, like I said, I think that the space of generative art is not just something different. It's not just bigger, or you're making more of something. I think it's meant to be experienced a little bit differently. I think one way to think about this is that in traditional generative art, or in generative art now, you find people that are seeking particular things. But I think that when you have fluid art, it's more about like experiencing or surfing it, or just kind of going in and experiencing the space. So I think it's a different kind of experience when you're immersed in the parameter space itself. So like I said, this isn't a fully formed idea. It's a set of ideas that I'm kind of coalescing around. But I think the claim I'm trying to make today is that I think generative art is liquid. It doesn't really exist to make outputs, which is what people think of it now. Is that people think that you make an algorithm and it spits out 50 or 100 things. I think it's more of a medium to be experienced directly. And it's my hypothesis that it is possible to experience this without ever compressing it to solid form. So compressing to solid form means when you had the Bach Sonata generator in it, you destroy the generator, but you keep the outputs. That's essentially taking the algorithm away and leaving the artifacts. And I think it's possible to experience generative art without doing that. I've just started a research project to explore this. And so you can check back with me in 2 years and see if I've had any luck. But I'm going to try to build an online site around these conventions, around the idea of collage and parameter space and kind of social interaction, in which these algorithms, so some of these things like art blocks or FX hash or Metropolis, where these types of artworks can be experienced in kind of a fluid way, but we'll see. And that's the end of my talk. Thanks. So we've lost JC. Are you the new JC?
Good shoes to fill.
Yeah. Does anyone have any questions? No? Well, if you are interested in this, like I said, it's something I haven't really figured out. So if you have ideas about this and you'd like to give me feedback, feel free to look me up. There's my name and URL, everything. Drop me an email.
Okay, I have one simple feedback because thank you for sharing with your insight and artworks of generating art. And because one of our material requirements is to create a generative art too, so I think your extensions can help students to get some inspiration, because I think most students don't know how to jump to the art, because we lack the thought for that, because we always do the things that people ask us to do. But art is thinking and to see how we can create something, and like using the machine learning and to use the machine to watch things. So I think your presentation is very inspiring for us, yeah, and very helpful to them.
Oh, thank you so much. Yeah, like I said, the first talk was mostly about me and my artwork, and hopefully that was my path through this space. But maybe it can be an inspiration if there's something that the ideas that you want to combine in a technical sense and an art sense. There's a whole world of possibilities there. And then the second talk, I guess, is a little bit more just kind of what this generative space should be. And hopefully that's relevant to your blockchain stuff, because I think too a lot of times when I said the word skeuomorphic, I don't know if you have heard this before, but a lot of times when you're designing a user interface, when Apple comes out with the Notes interface and it looks like a notepad, and it has a little pencil on it, that's called skeuomorphic, because you have a physical set of ideas and you just kind of copy them digitally, and people know how that works, and that's easy to understand, but that's not really how the computer works. And it's kind of there's a lot of criticism about using skeuomorphic principles in design, and I think the same is true on the blockchain. I think that just because people and my focus is on art, so just because people are used to buying paintings and you have one painting and you sell it to someone and you're the buyer and you're the collector and this is the artwork and scarcity and all, just because those are the conventions of the physical world, the dumbest thing to do is to cut and paste that into the digital world. And I think the blockchain actually gives you a lot of possibilities for all kinds of other ways of structuring the world. And so I guess I would encourage people not to blindly copy what we do in the physical world, but to think about, it doesn't have to be about art, but think about, is there other ways of structuring transactions and essentially moving value around that we can't do in the real world, that might be more native to digital world. I don't know if that made any sense, but there was a theme there that, and I hopefully, I think that some of my frustration with how the art world is basically being cut and paste into the digital, I think that's not unique to the art world. I think a lot of things are going to be migrating into the blockchain space, and we have a chance to do it better. And hopefully we always will try to think about a better way to do it and not just copying the way that we were doing it before.
Okay, let's give the answer. 那同学这边问一下，就是期中这边大家有什么问题？期中报告，我们是下礼拜的期中报告，然后每个人是4分钟。
我那个钱包好像有问题，我可能上不了链。
今天这个昨天有公告，就是请大家上去填一下钱包地址，然后我会把那个币空投给大家，大家之后才能够铸造，不然你们现在没有币，应该是铸造不了。还是你不是币的问题？
我是钱包的问题，之前不是
钱包。好，那我等一下帮你看。对，如果真的好像也有人来写信来问，如果真的上链，如果上不了链也没有关系，那只是可能就没办法参与那个加分的部分，但是对其中的分数不会有任何的影响。这样子，
我可以把那个客户的这一点帮我上。
好，我们等一下来看一下，这样对。I took all the midterm requirement。对，好，那这边的课堂应该就到这边，好，谢谢大家。OK， thank you。
Thanks for
Yeah. Let me stop.
Hello.
Hi.
My university.